Okay, so then perfect timing. Thanks for joining. So I hand over to Shane O'Mara to talk about the praise of walking.
Thank you, Martin, and thank you for the opportunity to come and speak with you today. Martin asked me to speak to you because I've written this book recently on what my editor called the new science of walking. I'm not certain it's entirely new science, but what I've tried to do is tell the story of human walking from a different perspective. So there are many books available on walking and humans, some from a very anthropological or evolutionary perspective, others from the perspective, for example, of very individual accounts of long walking journeys. And there are some books such as Waypoints, which is just about to appear. But what I'm trying to do with this book is tell the story of human walking from, I suppose, what you might characterize as the inside out, from a brain's eye point of view, and from the outside in, how the environment can change how we walk. So what I want to do over the course of the next half hour or 25 minutes or so is give some new perspectives on how we might think about human walking. Let's start with a quote, and this is a quote from John Napier, the British anthropologist who produced many interesting works on human walking during the 1950s and 60s. And he says, interestingly, that human walking is a unique activity during which the body, step by step, teeters on the edge of catastrophe. Now, I think that quote is half right and probably mostly wrong. And I want you to look briefly at this picture, or this little film of John Cleese, whom I know is very famous all over the world. He's performing his walk as one of the members of the Ministry of Silly Walks. Look at his eyes, not his feet. And what you see is something really interesting. His head is stabilized in space. His gaze catches a passerby. He nods and engages to, or with, and nods to that passerby, all the while engaging in a series of forward movements which appear to teeter on the edge of catastrophe, but never do. One of the lessons to draw from a little clip even like this is how intensely social human walking actually is. And one of the key points that I think bears further analysis over the coming years is just how much our social brain drives our individual walking and vice versa. We evolved in a context where we walked together out of Africa in families, in small units, in tribes, in groups. We didn't evolve in a context where it was one person heading off into the wilderness with a spear. We had to do this together. So we're very keenly attuned to what it is that others are doing when we're walking. Now, let's just go back to the start of our own journeys as individuals learning how to walk. If you follow the normal course of learning to walk, you'll have started somewhere around the age of a year or so to pull yourself from four limbs, where you're in a very stable position, gradually up onto two limbs, where you're in apparently a very unstable position. And this transition has not been studied in the detail, perhaps, that it might have been. Instead, what we have are developmental milestones. But the natural history of the development of walking is something that has really only taken a view in the last number of years. How do we learn to walk? We learn to walk by making thousands of steps and dozens of falls per day, in this wonderful paper by Karen Adolph. How do they demonstrate this? They demonstrate this by bringing an individual or a child rather, to a walking laboratory where there's a gait map and plenty of obstacles for the child to climb and walk around upon. And they track the position of the infant as it's moving around in three-dimensional space. And the lesson is very straightforward and something that's overlooked in our modern lives. The amount of locomotor experience that a child gains is absolutely astonishing. The average 12 to 19-month-old averages around about 2,368 steps per hour. And going back to Napier's comment, the child falls about 17 times per hour, but not catastrophically. It falls typically safely and gets back up again. So you have this unfolding of a program that demands immense amounts of time-distributed variable practice, which is the natural practice regime for learning to walk. Now, coming all the way up to a fully developed adult, one of the things that adults are extremely good at doing, and indeed children are good at doing, is walking in nature, walking in wilderness, but in particular walking on surfaces that offer little stability. And again, this tests Napier's idea that we walk on the edge of catastrophe. So what I want to do is just look briefly at this video from Mary Hayhoe's laboratory. And what she shows here is a mobile walker equipped with a lab in the wild, spotters on his limbs, moving across a surface which is perhaps quite dangerous, and moving with great speed and facility. And the question is, how do we do this? And you can see the walker is about to arrive at the end point here. Again, the phrase walking on the edge of catastrophe comes to mind, but no catastrophe befalls this walker. And indeed, you will see many runners who can run with great facility on surfaces like this as well. How do we do this? Well, this is how we do it. We look about 2 meters ahead and we flick out our eyes, and then we flick them back and we place the foot where the eye has recently been. So we make a decision about the stability of the platform on which we are about to place our own 2 mobile platforms, namely our feet, within about a fifth of a second. So this is a remarkably fast decision-making process, and humans turn out to be remarkably good at doing this. And again, notice the great stability of the head as it is moving through space, even during that slight stumble that the person engaged in there. Now, just to change gears for a moment, I want to talk about the effect of walking on our bodies and brains, and how that might be good for us in the sense of offering perhaps a preventative treatment for major depressive disorder. So I've chosen a simple study. This is conducted at Iowa State University, which focuses on what's known as incidental ambulation. In this study, students or participants are brought to the laboratory ostensibly for a task where they have to judge the beauty or otherwise of photographs of buildings around the Iowa State campus, or they have to go and view them in person. So they're walking to those buildings. It's not an exercise routine, it's just incidental ambulation, ambulation that is incidental apparently to the task at hand. The person provides a variety of ratings, including ratings of their current state of affect, and then they undertake the task. And what you find is quite a dramatic change in the persons who have walked. Their own self-rated affect rises quite considerably over those who have remained seated for a similar period of time. Now, this could be an idiosyncratic result, but it turns out not to be. There's been a lot of interest over the past decade, and in particular in the last couple of years, where interest has accelerated in the use of exercise, and in particular walking, as an intervention for the prevention of depression. And this very impressive piece of epidemiology, which comes with all the warnings that epidemiology comes with, follows a cohort of 34,000 adults over 11 years. They have no common mental disorders or limiting physical health conditions. And what they find is when you look at movement, and in this case, physical activity is principally walking, that activity of at least 1 hour per week prevents approximately 12% of future cases of depression. And in several commentaries on this and related works, Psychiatrists have commented that the effect sizes seen here are approximately equivalent to that seen in cognitive behavior therapy and in drug therapy. But the general conclusion is one, that we need to move more, that regular leisure time exercise of any intensity provides protection against future depression. Curiously, in this study, not anxiety, and there may be other reasons for that. It's often said that walking provides a boost to creativity. And there are lots of ways of thinking about how that might be the case. But the general point I would make is that psychology and neuroscience has come late to the creative walking party. So this is a picture of Sir William Rowan Hamilton, perhaps the greatest of Irish mathematicians and a renowned walker. He invented the mathematical system of quaternions, which are a very peculiar and alien mathematics to everyday experience, but are widely used now in physics, particularly in computer gaming and computer graphics. And Hamilton would think about this theory on his daily walks from Dunsink in the North City in Dublin to Trinity, which is about a 2-hour walk, about a 10.5-kilometer walk. And one day he figured out the equation in 1843, but lacking a pen and possessing a tobacco knife, he cut the equation into a stone on this bridge. And the equation is there. I won't go through the detail of the equation. But he described the feeling as one of a spark flashing forth, which is a really great way of describing the aha moment. Now, is this something that's peculiar to him, or is it something that's somewhat more general? Well, there are lots of ways of testing this, but in this very interesting paper by Opezzo and Schwartz at Stanford University, they brought people to the laboratory ostensibly for a task focused on creative thinking. And a simple way of engaging in creative thinking or testing creative thinking is to ask people to engage in what's known as a divergent uses task, where your task is to generate new uses for common household objects, such as cans or pens or pieces of paper or paper clips or whatever it might happen to be. And they show in this paper that people who engage in a prior period of walking of perhaps 10 minutes or so generate about twice as many ideas compared to people who are seated for that same period of time. And the effect holds true on a treadmill, remarkably enough. And this effect also turns out to be present in an older population compared to a younger population, whereby older adults in their late 60s and early 70s perform about twice as well as a seated young population in their late teens and early 20s at this particular divergent uses task. Now, it's often said when you're walking that you might walk in circles, and an interesting question is whether or not this is true. And this lovely paper by Jan Suman and colleagues actually tests this hypothesis. They test it in a forest in Germany where cloud cover is present or absent, and they also test it on open airfields on the apron of where aircraft would normally land, and they also test it in the desert. And what they show is that in the absence of a homing beacon, that we walk in straight lines for perhaps 10 or 20 meters, or maybe a little bit more. But then gradually the vestibular system becomes miscalibrated and we start to walk in circles and we turn back on ourselves. And this effect does not depend on whether you're left-footed or right-footed, and occurs in people who are blindfolded while walking as well. This leads us naturally to think about how we might represent our visual environment, our spatial environment. We owe the phrase the cognitive map to Edward Tolman. In a famous paper in 1948, he introduced the idea of a cognitive map. Tolman was considering the issue of how it is that animals know where they are in the environment. And he tested this using this particular apparatus here. The animal would walk into the bottom of this maze, would cross in a straight line through into this little covered area, make a left turn, move forwards, make a right turn, and retrieve a food pellet from this little array here on the right. And then if the maze was converted so that it adopted a sunburst pattern, Tolman then wondered what the animal would do. Would it repeat the motor movements that it had previously engaged in order to, for which it had received reward, or would it figure out somehow that the reward in the environment is in a different place to where, is in a place that requires a different sequence of movements to those that it had previously been rewarded for. And in this early paper, you see that Tolman is right, that motor reinforcement theories or motor reward theories can't explain this pattern of behavior, where animals will go to places in space using movements that had not previously been rewarded. And Tolman took the view that somehow the animal was inducing something that he described as a survey map of their environment. A number of years later, John O'Keefe was to show that in the hippocampus, you have these wonderful cells known as place cells, which fire as a function of the position of the animal in space. And here's an example. This is from my lab. You have a rat walking around in an open field, retrieving food pellets. And there's a neuron discharging. It goes silent. And you can see the animal, and then the neuron fires again. And you can see that the animal covers the whole of the arena, but this neuron fires only in the upper right-hand quadrant of the arena. So this is a so-called place cell. We also have other cells, head direction cells. This is from Jeff Taube's laboratory. And these cells act like a compass, signaling the direction of the head in three-dimensional space. This is a cell recorded in the you can hear the discharge there in the anterior thalamic nucleus, the dorsal anterior thalamic nucleus. These cells go from a resting rate of 0 hertz to 100 hertz in a very, very short period of time. They're really quite remarkable cells. So putting together a sense of direction with a sense of place gives you the elements of a cognitive map. And O'Keefe was to win the Nobel Prize in 2014 for the discovery of place cells. And Maybrit Moser and Edvard Moser were to share that prize for the discovery of the so-called grid cells, which provide a metric for space. Now let's shift gears again. And what I want to do is talk briefly about living in our modern world. Most of the population of the planet lives in urban areas, and that means most of our walking will be urban. It will be in towns and in cities. Our streets used to be terrible for walkers. This is an example from London, where chamber pots would be emptied out windows and boot scrapers were present at the entrances to houses to remove the effluent from people's shoes. And our streets are still quite terrible for walkers in many respects. And I want to put this in a particular context. Everywhere we look, everyone is living longer. And the average age at death has been rising consistently over the past number of decades. However, when you examine how walkers who are older find the ease of walking around our towns and cities, this is what you find. That most older pedestrians find it difficult to cross the road in time. And the older pedestrians with mobility impairments are typically ignored where walking our towns and cities are concerned. So this is an important study by Laura Asher and her colleagues in the UK. They tested 3,000 adults aged 65 plus, and they found remarkably that 84% of males and 94% of females had a walking impairment. And this walking impairment was such that the vast majority of walking adults could not cross the street at a road crossing in the time that is set for that road crossing, which suggests to me at least that people who should be at the center of how we think about how we design our towns and cities in terms of how we can walk around them are ignored. This is my hometown of Galway on the west coast of Ireland, and our town planners have just reconfigured one of the major roads, and they've removed all of the crossing points so that to get from one side of the road to the other takes an average of 14 minutes because cars are prioritized over individual movement. Really quite remarkable. Now, how much do we walk as individuals? People are very bad at estimating how many steps they take per day. And thanks to smartphones, we have a very good sense of how much it is that the average adult actually walks. And it turns out, compared to a child, it's not very much at all. As I mentioned, a child learning to walk walks about 2,300 steps per hour. The average adult in the developed world walks about 4,500 steps per day. So really, there are quite dramatic declines in activity across the life course. But the towns and cities we live in make a huge difference to how much we can walk. So this wonderful study by Tim Eltoff and his colleagues quantify that. In addition to showing how few steps we actually walk, they show that there is a dramatic variation in the amount of walking we do depending on the towns and cities we live in. And in highly walkable cities, we walk a lot in the morning, again at lunchtime, again in the evening, and we walk a lot more at weekends compared to towns and cities that are less walkable. This is a US sample. If we look at, this is a study that has just been published focusing on the Hadza who live in Africa and who live a hunter-gatherer lifestyle. And what they show here, compared to Western populations who are here in the black line from mobile phone data, that the average Hadza male and female walks dramatically more than the average Westerner, about twice as much in the aggregate, but there's dramatic variability in the walking as well. And you can see some walkers, especially in this male group here, there's greater dispersion, have put in up to 60,000 steps in a day. So that's a really remarkable amount of walking. Far more than we're used to doing in a high-income country. But the key point I want to make is that pedestrians are too often ignored in favour of motorists. And if we're to think about walking in our towns and cities, we need to think about it in an all-embracing fashion. We need to think about it in terms of how easy it is to walk, how accessible our towns and cities are for everyone. That includes people with mobility impairments. How safe our towns and cities are for everyone, and indeed how enjoyable our towns and cities are for everyone. This is one of my favorite places in Italy. This is Taormina in Sicily. And one of the wonderful things about Italy is this phenomenon at the Passeggiata, where people go for walks together in the evening, building dramatic amounts of social capital. Okay, so what I want to do now is just change gears again a little, thinking about dementia and physical activity. The Lancet has produced, or the Lancet Commission has produced two papers in the last 3 years, one in 2017, which I'm focusing on here, and a more recent one in 2020, focusing on the issue of dementia prevention and what we can do to prevent dementia over the course of one's life. And this is their life course model. They estimate in their early model that about 30% of cases or 35% of cases can be prevented by modifying things that we do over the course of our life. In their latest model, they estimate that it's about as high as 40%. And at the core of their dementia-proofing strategy for society is an increase in the levels of exercise, and walking as a particularly accessible form of exercise over the lifespan is one that we should, in my view, be focusing more on. Walking, of course, exercise produces a variety of anti-inflammatory factors in the blood. It allows you to enrich your social network, and it decreases hypertension and risk for diabetes, and also, as we've already seen, decreases your risk for depression or major depressive disorder by a not inconsiderable factor. We can see that regular bouts of walking have profound effects on individual brain regions. This is a study from Art Kramer's group in Chicago, or in Illinois rather, where they, at the Beckman Institute, where they've focused on regular walking in a group of 120 older people. One group are treatment as usual, so they're left at home. Another group are taken out for regular walks, and they show that an exercise intervention increases the volume of the hippocampus, which is, I've already mentioned, and concerned with spatial memory, but also has a remarkable effect on memory performance, and causes an increase in the circulation of brain-derived neurotrophic factors as sampled in the blood. And the age-related performance of individuals over the course of this intervention suggests that they move backwards, or move from an average age of about 70 in their age norm performance to an age norm performance of about 68 to 69. So exercise can have a remarkable effect on not just the physiology of the brain or the anatomy of the brain, but also on the function of the brain. So I would like to conclude by saying this is what we should be doing much more of: less seating and more activity. My book has recently come out in German, and you can find me on socials at these various places. Thank you very much.
Okay, so thank you very much for this brilliant talk. So I have a couple of immediate more comments somehow. So I was very pleased to see, well, your comment about Hamilton, because I've been using as a physicist Hamilton all the time in quantum mechanics. This operator is called the Hamiltonian that is driving the wave function. So quantum mechanics is full of, obviously, this Irish mathematician, and also the invention of the quaternion. So there are some speakers of today that actually using this for their computer programs for well, managing 3D operations in space. So that was really helpful. Now the other part is I'd like to thank briefly Romani Sambo to bring to my attention your book, which I've started reading while sitting. Then I started reading while standing, and then after the 5th page or so, I started reading while walking. And when I was reading your book while walking, I read that you've been written this book while walking, more or less. So that was very impressive. But I think using a
dictaphone.
Dictaphone. And so another remark. You mentioned this the 1.2 meter per second walking speed you need to cross safely the roads, and in particular a problem for elderly people. So indirectly you're saying, well, walking speed in real life is decreasing with age, which is one of our most important arguments with the regulators to try to convince them that real world walking speed should be an accepted outcome measure for clinical trials in a wide range of chronic diseases. And so far, we've always been using arguments from evolutionary biology, Daniel Lieberman, that you also mentioned in your book. And there are very good arguments that we are fantastic runners, but I think in your book, there are all those arguments collected that we are really also very unique walkers, long distance walkers. And so it's full of arguments, I think, to be used to also bring to the attention of the regulators the importance of walking as outcome measure and also as treatment option. So that was really very encouraging. Now, well, okay. So, but these were just comments. So I'm sure that we have time for a couple of questions. Not too many because we're a bit late. Jörn?
Yes, this has been fascinating, and it resonates with a lot of things that I find true. Do you really need? I think that it's the whole package of walking, or are there some particular effective agents within the walking? I mean, is it the motion through the space? Is it the endocrine environment? What do you think?
I think it's difficult to tease apart any of these causally at the moment because we don't have sufficiently fine-grained studies, so it's almost a case that you can choose the variable that you're interested in. So you've mentioned the endocrine system, and there are certainly profound endocrine effects of walking. We also know as a result of studies over the past 10 years or so that myokines are being produced during physical exertion, which wouldn't be produced if you weren't engaging in this physical exertion. But we equally know that people are remarkably attuned to each other when they are walking. We are astonishingly sensitive to the motion of others. If we make intercepting movements when somebody's walking to us, we can judge where the person is likely to be with great ease. And we humans do something which is really quite unusual in the animal kingdom. When we're wanting to protest over something, we gather together and walk together. A chimpanzee troop would kill each other, they would tear each other apart. But humans will, in fact, walk to protest over something that is, in essence, cognitive. And we undergo unusual ego boundary dissolution effects when we're walking together. We find ourselves, when we're part of a large protest or walking towards a rock concert or whatever it happens to be, where we feel a slight dissolution between the boundaries of self and other, and we feel ourselves merging with the group that is around us. And we're very good at coordinating our behaviors in these circumstances in ways that are denied other animals in the animal kingdom. So I would be very much inclined to the view that we need to think about walking on multiple levels. We can think about it in terms of health benefits, which is fine. We can think about it in terms of social capital building, which is fine. But we can also think about it in terms of relationships with each other. But equally, we need to think about how it's constrained. Our built environment has a dramatic effect on how much walking we can engage in. And the nature of that built environment, whether it's green spaced or whether we're exposed to traffic or whatever, has a dramatic effect on the amount of walking we can engage in too. But in general, the kind of point I would make is that when you look at activity levels in high income countries, walking is the most accessible form of activity that we engage in during the day. And we do an awful lot less of it than we used to 100 years ago because we have data on this. And we do substantially less than people in so-called hunter-gatherer societies do, who have wonderful cardiac health, among other things.
Okay, I see, Morten, you've raised your hand.
Yeah, it was, I almost got an answer to my question. It was based on the fact that in Denmark, walking is not really talked about, whereas running is really promoted. So my question was sort of walking versus running, but I think you answered that. I'm all in for walking now.
I think, you see, this is there's an interesting life course question about physical activity, isn't there? And walking is an activity that you can engage in from about the age of 2 until the age of whatever, 99. But running is something that's very hard to do. Your peak capacity as a runner is probably in your 20s and maybe your 30s. But people typically don't keep it up as a form of physical activity late into life. There's an enormous attrition rate. But walking is something that we can all do. But the argument I'm making in my book is not an anti-running argument. I think if people run, play squash, whatever, that's all wonderful. But what we do need to do is to design our society to facilitate much more walking than we actually do. So the example that I give in the built environment is my own building, which sadly haven't been in for a long time because of the current pandemic circumstances. But to get to my office, it's on the 3rd floor. You have to take the elevator, which is just in front of you. If you want to get to the stairs to walk up to my office, you have to go through 3 fire doors. So the building is designed to take movement out. And this is something we will have in that building until it's torn down in 100 years or 200 years or however long it will last.
Okay, I think I have had some success in telling my colleagues that they shouldn't use the elevator, they should walk.
But the affordance of the environment often is that you have to take it because it's the option in front of you. If the architect designs the building so that the stairs are what you take and they're comfortable rather than these fire stairs that are buried in the corner, then you're in a different place. So the re-engineering how we live is actually a considerable job.
Okay, so now I'm afraid that I have to now stop this discussion. We may continue in the first break that will be extended somehow. So I'd like to thank you very much